Okay, practice exam 1. And get some paper. Come on, come on. Okay, exam 1 review. Because we already did this once, right? So now, presumably, after studying all weekend, you know precisely what you do not know. Okay, now, watch the magic. Woo! I love it. Okay, now hold that thought. Be thinking about what you had trouble with over the weekend. I've got to get my coffee. Okay. So, let me show you what we went over on Wednesday. Ah. Already exists. Never mind. Never mind. Don't get all upset. That's right, I completely forgot. Exam 1 Review 2. Where's Exam 1 Review 1? There. No, that's correct. I believe this is yours. So let's see, we started off going over this. Perpendicular lines. And then this, if that's it, let's see if this is it. Oh, that's where I am. Okay. Perpendicular lines, so we talked about that. Oh no, this is the difference quotient. This is perpendicular lines. This is systems. Okay, this is perpendicular lines. This is the difference quotient. This is a matrix, so we did a matrix on Wednesday. So now, why don't we take up from there?
Can we go over like the word problems with the Gaussian method?
Say it again?
Can we do like word problems with the Gaussian method?
With the what method?
With the Gaussian method?
Ah, okay, the Gaussian method. Let's see, we're in the practice exam. Let's see if there is one. We'll just go through them.
On the test itself, will it be 34 questions as well?
I actually don't recall. Let's look. Oh, rats. There we go. MyMathLab. Oh, let's get rid of this. MyMathLab. Oh, that's the practice test. All right, the exam. It is not going to tell me because people have already been taking it.
Okay.
So I can't get in and look. So I don't remember. Actually, though, there's a way. Wait a second.
It's 25 questions.
25.
Okay, great, 25.
Thank you.
So we were still looking to see if there's a word problem that is a matrix. And I actually don't recall doing that, but I might have.
I believe on the practice exam, it's either 30 and 34, I believe.
Okay. So we will do that. Whoa, I was going to go in there. Oh, that's the practice exam. All right. Little disorganized. That's why I had to go get my coffee. Okay, so let's do that. Let's go to the end. Oh, we're in exam 1. There are 25 questions. I shouldn't be letting you see that. So we'll go to 30 and start looking there. All right, there's a regular matrix, and we did that. And another matrix. Ah, and here is a word problem. We'll do that. Let's see what 34 is. And 34 is another one. Okay. Now it says use Gaussian elimination. So we're going to do that. Let's read it. The Burks pay their babysitter $5 an hour before 11 p.m. and $7.50 after 11 p.m. One evening they went out for 6 hours and paid the sitter $42.50. What time did they come home? Okay, I have no idea. I'm not sure I even care. But no, we're not allowed to look at it that way. Okay, so the Burks pay their babysitter $5 an hour before 11 p.m. So I'm going to write that down. And this is what, number 33. And $7.50 per hour after 11 p.m. So there are two different kinds of hours. There are hours before 11 p.m. and hours after 11 p.m. So I could even make a kind of a chart. So before and after, and they go out for 6 hours. So the before and the after are going to add up to 6. Now let's see, one evening they went out for 6 hours. What time did they come home? Woo, okay. One evening they went out for 6 hours and paid the sitter $42.50. What time did they come home? Okay. Okay, well that means the total amount they paid was $42.50. That would be $5 for every hour before 11 p.m. and $7.50 for every hour after 11 p.m. And that would be $42.50. Okay, so actually there is no real need to, well, this is only a 2x3, right? It's 2 lines and 3 terms. So we can actually just use the regular old method you've been doing since beginning algebra of solving a basic 2x3 system. We can do that, or we can change it to Gaussian elimination, and I guess that's what they're asking for. Personally, I wouldn't, but let's do it. No, I'm not gonna, not when it's just a 2x3, you don't have to. I'm going to take the whole first line and multiply it by -5. What that's going to get me is -5x plus -5y equals -30. Meanwhile, I'm not going to do anything to the bottom line. Now we add both lines together, and the whole reason for multiplying both lines by 5, a -5, is so I could zero that out. -5 plus 5 is 0. So we will have -$5, and it would be better to write my dollars like this. Okay, that'll be $2.50 equals $12.50. Is that correct? Yes, it is. Okay. So then I'll divide both sides by 250. And I'm finding out the hours after 11 p.m. See, before 11 are X and after 11 are Y, and that's the way I wrote it here. So I'm going to get my calculator. And clear it. And say 1250 divided by 250 is 5. So Y is 5. Y is 5 hours after 11 p.m. Okay, well that would be 11 p.m. plus 5 hours. Would be 16 hours or 16 p.m., but there is no a.m., right? But there is no such thing as that. However, the way to convert time is to say, well, okay, the clock goes to 12, then it goes to 12 again, then it goes to 12, because we're on civilian time here. So I'm going to subtract 12, and that will make it 4 a.m. So the time they arrived home, which is what they're asking, what time did they arrive home? So this is not the answer. Yes, they arrived home 5 hours after 11 p.m., but what time was that? And the answer is they arrived home at, I'll just say arrived at 4 a.m. And I'm going to put it in here. Let's see if that's right.
If it's from 11,
Pardon me?
never mind, I got it. I was
Okay,
going to
great.
ask a really dumb question.
No, it wasn't. All that stuff about no dumb questions. Not in a math class. Nothing is obvious until you ask.
Can you work 18? I've done a really good job of guessing at the answers and getting them right, but I don't know how to work it.
Okay. Yes. Now again, the main problem with that isn't the graphing and isn't the shading. It appears to be finding the vertex, right? And that's what you're asking? Is that what you're asking?
I assume, I mean, I can't figure out how to get to the answer that I get to. I just guess, and I'm done well every time because of the y is greater than or equal to x. It is where it stumps me, like I'm not sure what I'm missing to get to the graphing part.
Oh, so it's the graphing part that's bothering you.
No, it's the actual finding the points that you graph.
Oh, okay. Well, let's just do the whole thing. We'll do it fast. That is not acceptable. Okay, our system of inequalities is y is less than or equal to x, and y is greater than or equal to 5 minus x. Okay, step 1. Change them just to straight lines. Step 1 is just finding out how to graph the straight lines. And these are going to be solid lines because you've got less than or equal to, greater than or equal to. Whenever you have or equal to, it's going to be a solid line. Okay, so to find 2 points, let x equal something and find y. You can choose easy points. You can choose 5 million if you want to. But it's easier just to choose easy points. So we could, for instance, choose 0 and 2. Now, whatever x equals, y equals, because y equals x. So if I put a 0 in for x, y will be 0. And if I put a 2 in for x, then y equals 2. So now I'll come over here and 1, 2, 1, 2, and the points that I am going to graph Let me do it in red. So these points will be red. So will the shading. 0, 0, and 2, 2. Okay, now I save. We find a test point. Oh, yeah, better to do it one at a time on your paper and then transfer it to MyMathLab. So step 2 is where we acknowledge that, well, come on, you know, this is not just the line, it's the inequality, which means you're going to shade one side or the other. So y is less than or equal to x. Normally I would choose 0, 0 as my test point, but hey, 0, 0 is on the line. You can't choose a point for your test point on the line. So why don't I choose this convenient point right here as my test point for the red line? And this point is 2, 0. Right there. So, okay, so my test point is 2, 0. Now, this is the x coordinate, I put that in for x, and this is the y coordinate, I put that in for y. So I get the statement 0 is less than or equal to 2. And I ask myself, is that true? And yes, of course it's true. So this point gives me a true, which means for the red line, I shade over here. Okay, now, now we're going to do the same thing to the other line. I'll let that be blue. And I'll erase that mark. Okay. So y equals 5 minus x. Again, I'm going to make an x and a y. I'm going to make it blue. An x and a y chart. And choose any points I want for x. And I made it too long. It doesn't have to be that long. You're just choosing 2 points. So I could even use the same numbers. I could use different numbers. We could keep it simple. Nah, let's not keep it too simple. How about x equals -1 and x equals +1? Okay, that means y is going to equal 5 minus -1 and 5 minus +1. So 5 minus -1 is 5 plus 1, which is 6. And 5 minus 1 is 4. So we have 2 points here. We have -1, 6, and we have 1, 4. Okay, so now I have to make some more hatch marks. 1, 2, 3, 4, 5, 6. And I don't know, that's about -1. So -1, 6 is going to be about here. Let's make it blue. And then 1, 4, here's 1. 1, 2, 3, 4 will be about here. And then I graph a line. Remember, all this is still on my paper. skinny line. Okay. Now that I have graphed the line, I acknowledge that this is an inequality. It's not just the equal sign. The equal sign is just the straight line part. Now I have to shade. So I go to what I go to what this really is, which is y is greater than or equal to 5 minus x. So I have to choose a test point, and now I can choose my favorite test point 0, 0, because 0, 0 is not on the blue line. So if I choose test point 0, 0, then I put a 0 in for the x and a 0 in for y, and what I get is 0 is greater than or equal to 5 minus 0. So 0 is greater than or equal to 5. I don't think so. So 0, 0 gives me a false for the blue line. That means I shade in the other direction. Oh, come on, what happened to my markers? Piddle. There they are. Okay. Okay, so we're going to shade away from 0, 0 because it gave us a false. Okay. Your solution area is going to be where the colors overlap. Now that you've done this on your paper, and you don't need to do it even exact as I did it, exactly as I did it, all you have to do is find out where the area is shaded to do the graphing. Now, you've already got 2 points for the for that. You've got 2 points for that. So you can graph this, you can graph that on MyMathLab, then you can drag your little paint bucket to the area of overlap. Meanwhile, finding the vertex is going to consist of taking the equations of the two lines, y equals x and y equals 5 minus x, and solving those as a system. Well, this is ideal for the substitution method you learned when you were learning about systems back in beginning algebra. And here, since y equals x and y equals 5 minus x, they've got to equal each other, right? If y equals this and y equals this, and we know that y is y, so I'm going to use the equation x equals 5 minus x and solve for x. To x equals 5. X equals 5 over 2. Well, great. But what is y? Well, conveniently, once I get an answer here, I can go back to either equation and substitute. So if x is 5 over 2, y is 5 over 2. Or you could do it in this one, y equals 5 minus 5 over 2. And if you're stuck doing this by hand, you can always do that in your calculator in Math Bracket. But if you don't have a TI and you don't know how to do it on your calculator, then what would you do? You would get the same denominator. 5 can be written as 10 over 2, right? 10 divided by 2 is 5. 10 over 2 minus 5 over 2 is 10 minus 5 over 2, which is 5 over 2. So x is 5 over 2 down here. Y is 5 over 2. So now we know that the vertex for this problem is going to be 5 over 2, comma, 5 over 2. And that is, let me reduce the size on this. That is the whole story on number 33.
$18.
18, somebody yelled out, oh, this is 18, we just did
This is
18.
18, yes.
Oh, that's right, it's not 33. Okay.
Miss Rodemaker, the top was 33. If you go down to the middle page, that's where 18 started.
All right, thank you very, very much. Thank you. Yes, I see that. Okay. Okay, sorry. Yeah, click there. Okay, now what? Just trying to make the page bigger. So it's just not cooperating though. There, that's what I wanted. Okay. Is anybody there?
Yes, ma'am. I'm trying to look through mine and see if I made the same mistake on more than one try.
That sounds good.
Can we do question 25?
Yes. Yes. Okay. Okay, step one is to isolate the radical. That means you've got this plus 2 out there. We need to move it over. Okay. Now, once I have my radical isolated, my square root radical, I am going to do step 2, which is square both sides. So I'm going to square the left and square the right. Squaring a square root gives you what's left underneath. Squaring a binomial that's not a square root is a different matter. Okay, now I'm going to have to multiply these together. Negative 2 times negative 2 is positive 4. Okay, now that I've got a quadratic equation, I have to pull everything over to the side where the x squared is positive and set it equal to 0. So I will subtract the 2x from both sides. And I will add 1 to both sides. And the whole reason I do that is that 2x minus 2x is 0. And negative 1 plus 1 is 0. So I get 0 plus 0 over here equals x squared minus 6x plus 5. Okay, 0 plus 0 is 0. So x squared minus 6x plus 5. Now, by now, you know you can use the quadratic equation, the quadratic formula on this, but it's factorable, and factoring is so much faster. Now you solve the quadratic equation. That's not an official step 3, because you don't always have a quadratic equation, but you do solve for x. So I guess that would be step 3. It would probably start higher up. Okay, we're going to have, there's a 1 in front of the x squared, so we get to use the faster method of grouping. 5 equals 1 times 5, and 5 times 1, so we don't even have to repeat that, but it also equals negative 1. Negative 1 times negative 5. And negative 1 plus negative 5 add up to the middle number, negative 6. So they're the numbers I want. I'll put the minus 5 here and the minus 1 there, and the minus 5 here, and then I set each factor equal to 0. This is called the zero principle or the zero factor principle. You'll find different names in different books, but it's the whole idea of zero principle. You're going to set them equal to 0. So I add 1 to both sides, I get x equals 1. I add 5 to both sides, I get x equals 5. Now, if this were a regular kind of problem, you would stop there and say, okay, my two answers are 1 and 5. But, you can't trust this equation because it's a square root equation. It can lie to you. Just because these are the answers to this line doesn't mean they're the answers to the first line. So you have to actually go back and check your answers. Okay, so we are going to check x equals 1, and then we're going to check x equals 5. Well, you can just already do this and you can tell it's going to be false. I mean, really? 1 plus 2 equals 1? I don't think so. So this is false. What that means is that x equals 1 is not going to be an answer to this line right here. It doesn't mean it was wrong. It is an answer, a solution to this, but just not to the problem we're trying to solve. That's called an extraneous answer. Okay, 1 is extraneous. Now we check 5. There's no guarantee it'll work, but quite honestly, it usually, in the problems I chose, usually 1 doesn't work and 1 does work, but you can't depend on it. Not if you take other math classes. Or even this one, because you know how MyMathLab changes the numbers every time. So you could possibly get another answer. I don't know. Oh, this is going to be x equals 5. That's going to be 10 minus 1. That'll be the square root of 9. And you can already tell that is true. Square root of 9 is 3. 5 equals 5. That's true. So this is your only solution. And if you were to put in both solutions, MyMathLab would count you wrong. And I'm going to do that right now. I'm going to put in both solutions just as though I did not check it. Your input is incorrect. 0. Not even half credit. Okay, now we're going to try 5. Your input is correct, 100%. So you do have to check. Now it is true if you upload your work to Module 5, okay, which is week 5, which is what this week is. Your scratch work, if you make it readable so I can read it, then whenever you miss a problem, I'll look over at your work and see if you need extra points, and not extra, partial credit. I do give partial credit if you upload your I hate to say scratch work because that sounds really messy. If it is really messy, I can't read it. So you might want to try to make it neat, or maybe somewhat neat. And numbering the problems really does help me. Okay.
Can we do 14?
Yes, we can. Let me write that down first. I don't want to go that slow. 14. Yeah, the perpendicular problem. Okay. Now the trick to doing this is to know that if you have one line, for line 1, if the slope is m, then for line 2, m equals 2/3. Let's just pick a number, 2/3. Suppose this is some line that has slope 2/3. If this line is perpendicular, that's the symbol for perpendicular, to that one, then its slope is going to be the opposite sign and the reciprocal. That's the relationship of perpendicular lines. So here we go. What you use that equation for that they give you is to find the slope of what's called the given line. That's the given line. Here's the given line because they give it to you. The given line is line 1. You're going to find out what the slope of line 1 is. Okay, I zeroed out the 7x's over here by subtracting 7x from both sides. And that looks like it's 1/5, which it's not. So before I get mixed up and everybody else does, let's put that up here really small. Okay, now this is +5. I'm going to put a plus in front of it. +5 plus -7x. So I'm going to reverse the terms because we want to get this in slope-intercept form. And the reason I want to do that is that I want to find the slope of this line. Okay, so the slope of this line is -7/6. And you can just tell right away if you get this in slope-intercept form. Now, watch what I do. I'm going to find the equation of the line now, and they gave us a point. This is called the given point because they give it to you. y minus -3 equals m times x minus 6. This is my x1 and y1. And what I'm using here, I should have written it first, is y minus y1 equals m times x minus x1, which is called the point slope formula. So I should write that too, since we're reviewing. Okay, so this is y plus 3 equals, I have to take the opposite reciprocal of -7/6. Okay, so the opposite part means opposite sign. So since this is negative, this is going to be positive. And the reciprocal means I take the two numbers and flip them. So this will be positive 6/7 slope. Okay, I'll let you think about that for a minute while I guzzle some more coffee. Okay. Now, I don't like ugly fractions. And we don't have to deal with them because of the trick. I'm going to make it in blue. The trick that says if you want to get rid of a fraction, multiply it by its denominator. All right, if I were over here, I'm going to write a note. Over here, if I want to get rid of that fraction, all I have to do is knock its knees out from under it. That would hurt. All I have to do is multiply by the denominator. Now what that does is that makes that 7/1 times, excuse me, times 6/7. When you're multiplying fractions, when this number and this number are identical, they cancel out. So you're left with 6/1, right? 6 there, 1 down there, and 6/1 is just 6. 6 divided by 1 is 6. So this is my strategy. What I'm going to do is multiply both sides of this equation by 7. Here I've got a fraction that I'm multiplying, so I say 7/1, but over here there aren't any fractions, so I just say 7. And then once I do that, and I get rid of those nasty fractions, what I'm left with is 7 times y plus 3 equals 6 times x minus 6. And then I'm just going to work this like a normal problem because the fractions are out of the way and I know how to handle this. I'm going to distribute and distribute, and I'm going to distribute and distribute, which is just the name of multiplying a number into parentheses where you have more than one term. So 7 times y is 7y. 7 times plus 3 is plus 21. 6 times x is 6x. And 6 times minus 6 is minus 36. And that's what I've got so far. Now, all I have to do is solve for x. Notice that the instructions down here say, type your answer in slope-intercept form. Slope-intercept form is y equals mx plus b. So that's what I'm going to do. I'm going to subtract 21 from both sides of this equation. Actually, I don't need to go over there. 21 okay, so 21 minus 21 is 0. I'm left with 7y equals 6x. Now I take away 36 and I take away another 21. That means altogether I've taken away 57. And then I divide by 6, I divide by 6, and I divide by 6. No, I don't. I lied to you. Don't let me lie to you. Don't just take it. I divide by 7. What good is it going to be to divide by 6? Silly teacher. There you go. That's why I do it. Y equals 6/7 x minus 57/7. And then I put that in here to see if it's correct. Notice they've already written the y equals, so all you have to do is write, whoops, that part. Let me get rid of that. Okay. So I'm going to come over here and I'm not going to write in the box because I have to type in the box. Okay, so 6, 7, I have to hit the right arrow to come to the right, x minus, and here I think I can just say 57 divided by 7. Numbers are easy. I could have done that first, I think. Let's see if that works. Yes, it does. Let's see if the answer is correct. Yes. Okay. That's how you do perpendicular lines. Parallel lines, you're going to leave the slopes exactly the same. But for perpendicular lines, you have to find the opposite reciprocal slope. The problem is the slope. And remembering that. Okay. Now I have to add some more paper. So we finished this one. Let's go to this one. And we will get ready for the next question. I want to show you something first. Something's nagging at me. On the exam, okay. Here, I'm going over the exam really fast. Speed of light, but I'm looking for something in particular. Ah, there is a perpendicular line question. Okay, that's what I wanted to see. There is a perpendicular line question. So, yeah, you have to be prepared for it. And now we're back at the practice exam.
Okay, I know that we did 31. And 32 is supposed to be the same because it's also a matrix, but I can't seem to get 32 correct.
That's because it's easier. I promise you, you've made an arithmetic mistake. I promise you that's what it is. If you were able to get 31 correct, then you've got the method.
Okay.
The big killer here is silly little arithmetic mistakes, not big ones, little ones. I love to make little arithmetic mistakes and little sign errors. I hate matrices.
I make a
for
lot
that
of those.
reason. Hate matrices. That's a bad attitude, isn't it? Yes, it
No,
is.
because I have the same attitude.
Are you a business major?
No.
Okay, well, you don't have to take finite math then, probably. You should be patting yourself on the back there.
I am.
Yeah, okay. Finite math, you do more. I know I say that a lot, but it makes me grateful I don't teach finite math. Actually, it's a very interesting class. You also do probability. You do all sorts of interesting stuff you don't do in any of the other math classes. Except structures. If you're going to be a teacher, you have to teach structures.
My husband took finite with Miss O'Brien.
She's the best teacher we have, and she's retiring.
No.
Yes.
Oh no, that sucks.
Yes, it does. I just like having her around. She's so wonderful.
She is. She helped me so much when I was taking the intermediate math class before this one. I would go to the math lab and she would help me with my homework.
She's terrific. Everything about her is terrific. I've never found any flaws. That's scary. I want to grow up and be like her.
Right?
Except I'm probably older than she is, but forget about age.
Can we do 16?
Sure. I hate this problem, again, because I make arithmetic mistakes. Okay, the table over here, it says, this table lists data regarding the average salaries of several professional athletes in the years 1991 to 2001. Use the data or data points to, actually it should be pronounced data, but usually it's pronounced data. Use the data points to find a linear function that fits the data. Okay. Number 16. What do we know first? We know first that we're gonna, the question has to be in slope-intercept form. Okay. Now use the function to predict. That's what math is used for. It predicts. But you have to make an assumption that nothing is going to change in the future from the way it was in the past. And you know the chances of that. Okay, well, all right, again then. We're looking at average salaries of several professional athletes from the years 1991 to 2001. Okay, and okay, so you come over here, the first question. A linear function that fits the data is s of x equals. Okay. Now read the instructions or you're dead in the water. Let x be the number of years since 1990. Very important. Since means after. $1990. You're going to have to make yourself a table. That's the easiest way to do this. So if I come over here and do it, okay, 1990, and they're using S instead of X. Little s? No, they're using X. Okay. Okay, now I'll draw a line down between when I'm done. Okay. So year, I should have put year there. So 1990 is going to be year 0. X is going to equal 0 because that's the beginning year. Now X is the number of years after 1990. So 1991 is going to be year 1 and 1992 is going to be year 2 and so on. So I'm going to write the years 1993, 1994, 1995, 1996, 1997, 1998, 1999, 2000, 2001. Okay, so 3, 4, 5, 6, 7, 8, 9, 10, 11. And the years they're going to, oh, all right. Okay, now 2002, 2003, 2004, 2005, 2006, 2007. Now the easy way, actually it might or might not be easy, it depends on the person, is just to subtract 1990. But let us keep on keeping on. Because we only go to 2000. No, we don't. We go to 2010. Boogers. 16, 17, 2008, 2009, 2010, 17, 18, 19, and 20. Okay? That means that 2005 is going to be year 15, and 2010 is going to be year 20. And now you can refer to this table. You would get the same answers if you subtracted 1990 from all of these years. So that 2005 minus 1990 is 15. So you didn't have to go to all this trouble, but I think it helps in the beginning. Let me put this in the right place. If I take the time to put it in the right place, it will be better. Okay. Now, Here we go. M. You always find M first because we have to find the equation of a line that has these data points. 1991, 277,000, 2001, 1,450,000. Can you imagine? All right, well, you can look at this as X1, Y1 being 1991, 277,000, and X2, Y2 being 2001. Let's get rid of that M. 2001, comma, 1,000,004. 1,450,000. What are they going to do with all that money? Everything would be okay if they'd invest it. Well, maybe not, given the stock market. Okay, so first thing I have to do is calculate the slope. $1,450,000 minus 277,000 over 2001 minus 1991. Oh, we know the bottom's going to be 10, right? Let's see what the top is going to be. Clear. 1,450,000 minus 277,000. I want to make sure that's right. 4 zeros, 1, 2, 3, 4 zeros. Okay, up here. Enter. Okay, that's 1173,000. Then I divide by 10 because of the 10 down here. And I get 117,300. That is the slope. And
Will this
now,
class recording be on Canvas today?
I don't even know if I'm recording. I hope I am.
It looks like you are.
Yes, all right. Yes, it will. It takes about 2 minutes for it to process enough for me to upload it to YouTube. And then I put the link in week 5, where the other ones are already, I believe.
Okay, thank you.
Okay, that's M. Now, we need Y minus Y1 equals M times X minus X1. And my Y1, X1 is, but now we're being told, and I could have done it already, to use these numbers for the years, and that will make it easier. So let's see, 1991 is year 1. So this is going to be year 1, 277000. So y minus 277000 equals 117300 times x minus 1. The only easy thing in all this is minus 1. So y minus 277000 equals, I'm going to multiply that into there, 117300x minus 11730. The dangerous thing is going to be those zeros. Okay, now I've got to get y equals. I add 27700 to both sides. 27700. And I get my calculator back. Okay, so I'm going to have 277000, 27700 minus 11730, and I get 159,700. So y equals 11730x plus, because the bigger number is positive, plus 159,700. Now, if this is right, and I am going to put it in here, if this is right, then we can just do these other calculations quickly and easily on the calculator. So here we go. Everybody pray for me or send me positive thoughts. 11730 x minus plus 159,700. $159,700, 117,300. All right, everybody, hold your breath. They're not going to tell us? Enter your answer in each of the answer box. Oh, what a booger these people are. We've got to fill up all the boxes. Okay, all right, I'm not going to speak to them anymore. Now, I have to find out, I have to review here. 2005 is year 15 and 2010 is year 20. So 2005, y equals 11730 times 15. That's supposed to be a semicolon there, or a colon rather, times 15 plus 159,700, and then 2010 will be y equals 117,300 times 20 plus 159,700. And all we have to do is throw those in our calculator and we will come up with humongous numbers. Okay. So, okay. 117,300 times 20 plus 159,700. And 117,300 times 20. Oh, that was that one. Be careful. All right, 15. That almost messed me up. Times 15 plus 159,700. So I have to remember that my answers are in reverse order. Okay, so let me write these down. So 2015 is going to be 1919200, and 2020 2005 rather 2005 and 2010 is year 20. Okay. 2,505,700. Right, and this one is 1,919,200. Okay. Here we go. 2005. Oh, I can type it. 1,919,200. Two 505 700. Double check. 1,919,200. 2 505 700. Your input is correct. Woo! Okay, how immature of me. Now, if anybody wants to, I'm willing to keep going. If you have other things to do, that's okay too. Does anyone have any more questions?
I have a question.
Sure.
I know it's like a simple thing, but I keep messing up like the signs. So I was wondering, I think it's number 5. Could you go back to that one, please?
Sure.
No, it's not that one.
Okay.
I'm not sure which one it is.
Well, we'll just go to the beginning
Yeah, okay.
and start through.
Okay.
Okay.
No. 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 This one.
This one.
So I know how to like get the 5/8, but I'm not sure what sign goes with it. If
It's
it's
going to
the,
be 8 over 5. Oh, yeah, it is 5/8.
yeah,
Okay, that's what x cannot equal.
it's what x cannot equal.
Right.
Okay, because I keep confusing it with either A or C, but I know like what the fraction is.
Right. And you would get partial credit for that if you upload your paper.
Okay. Thank you.
Hey, good luck.
Thank
It's
you.
not luck, it's studying. I know.
I did study. My calculator it's not the right one, and I thought I had the right one, but I went out and I bought the right one. So I
Oh.
should be good now.
Okay, but the Casio is a good one.
Yeah, I bought another Casio. It has like more things to like do, because yesterday on my other Casio I tried to like simplify a square root, but it wouldn't. So I just had to like plug in the answer that way, but I know that that wasn't right. So this one works how I want it to.
Great.
Yeah.
Great. Okay.
Okay. Thank you. Have a good day.
You too. Anybody else? Okay, I'm going to shut down, okay? Going, going, gone. There are the sheep.